Hi guys, I'm glad you found the video. Tonight's homework is on converting rates. So make sure that you have a pencil and maybe a highlighter because I'm going to ask you to do some things as you watch the video with this worksheet. So you should have gotten this worksheet in class. So if you want to start to follow along with me, our objective today is to convert a rate. And just as a review, we've been talking about rates. A rate is a ratio where the numerator and the denominator have different units. So 50 miles per 1 hour would be a rate. It's a ratio. The numerator's in miles, the denominator's in hours. And if you think about our discussion of rates, both in science class and math class, we've often referred to a rate as a speed. And if you think about that, it's impossible to talk about someone's speed if you only have one unit. If I said, I'm going 50 miles, that's not telling me a speed. I could be going 50 miles in 5 hours. I could go 50 miles in 10 seconds. Depending on the time, that speed could be two very different things. We also talked about speed as being like words per minute that you type. We've also talked about speed or rate being like customers per day on how people are served. So today we're going to convert these rates. So for instance, if we had a rate in miles per hour, could we convert that and tell somebody how fast that is in feet per second? So we don't want to change the speed. We're still talking about the same person that's traveling 50 miles per hour, but we want to just convert the number so that it's written as feet per second. So in order to do that, we need to review some common relationships among metric and customary units of measure. So this will be a reference point for you. Some of the things that we will most commonly use, this one definitely needs to be memorized. There's 5,280 feet in a mile, inches to feet. These are all very important. There's a couple I didn't add in here, and that's when you convert time. So just as a review, remember that there's 60 seconds in a minute. So you can add that in. And one that we're going to talk about is how many seconds are in an entire hour. So if there's 60 seconds in a minute and there's 60 minutes in an hour, how many seconds are in an hour? Well, it would be 60 times 60 or 3,600 seconds in an hour. So that's going to be a common one that we use to jump from seconds to hours. On the metric side, I know you've already talked about this in science class, so there's some common ones that you can refer to. So this sheet is going to be very important for you. Okay, so then we continue. Each of the relationships in the table can be written as a unit ratio where the denominator is 1. We've already talked about unit rates when you did price comparison. We wanted to do how many dollars per 1 ounce. That was a unit rate. But now we're doing a unit ratio where the denominator is 1. So if you take a look at this, hopefully this doesn't blow your mind. It's not real difficult. 12 inches over 1 foot. It's a unit ratio because the denominator is 1. 16 ounces over 1 pound. 5,280 feet over 1 mile. And 60 seconds over 1 minute. These are all unit ratios. But if you look at the table and you use a little common sense, why did I pick 12 inches over 1 foot? Well, notice that 12 inches is exactly the same from up here as 1 foot. They're equivalent. If you remember from earlier in math lessons, or actually, let me backtrack a minute. If 12 inches is the same as 1 foot, what did you learn earlier in your math career when the numerator and the denominator had the same value? What was this fraction equivalent to? hopefully you're remembering that it's equivalent to 1. Anything divided by itself or an equivalent value is always going to be 1. So do you see that this fraction right here really has a value of 1? We're going to call this a special number 1. The reason I say it's a special number 1 is because many students look at this and they don't see 1. They see 12 inches over 1 foot. But I want you to start to see that this really has a value of 1. Same thing here. 16 ounces over 1 pound is equal to 1. 5,280 feet over 1 mile is equal to 1. And 60 seconds over 1 minute is equal to 1. So with conversion factors, if you can come up with these special ratios that have a value of 1, it's going to be very important for our process. So now if you look down here, remember from earlier math lessons, what happens to a number when it's multiplied by 1? So I'd like you to come up with an example to illustrate the answer to that question. Well, I'm going to use my very favorite number, 32. When I multiply it by 1, what happens to 32? Absolutely nothing. Its identity does not change. So the value of 32 did not change at all when we multiplied by 1. Therefore, whenever you multiply something by a ratio that is equivalent to 1, you're not changing the number's value, you're only changing the units. So what that means is if I take 50 miles per hour, if I multiply it by one of these conversion factors, the number might look different, but the speed hasn't changed. Okay, and I'll talk about that a little bit more. Okay, so let's try this first problem, and this is kind of the format we're going to use. I know that some of you will be able to do this in your head and you will not want to set up these fractions, but please trust me, we're going to add on multiple steps where you're going to need to use this process. So we want to go from 10 feet per second, and we want to change this to inches per second. We want to convert it. So the first thing you want to do is to put in your final units over here. Okay, so as you can see, our numerator is 10 feet, our denominator is 1 second. We want our answer to end up with inches per second. So do you guys agree that our denominator of seconds is already good? We don't have to convert that at all. The only thing we have to convert is feet to inches. Okay. Well, we're going to multiply by a fraction here, and whatever we put in this fraction, we want our units of feet to cancel, and we want our final result to be inches. So please write this in. Do you see that if I multiply by a fraction that has inches on top and feet on the bottom, what's going to happen to my unit of feet here? Do you see that we can cross-reduce that? It's going to eventually cross out, and our final answer will just be in inches per second. So that's the first step, is to set up in this fraction where you want your units to be. Now, I always tell kids to decide which of these units is the bigger unit. Whatever the unit is bigger, you're going to put a 1. So is an inch or a foot bigger? Well, a foot is bigger, so we put a 1 here. And then we look up here and we try to decide what value will go with 1 foot to make this a special number 1. Well, 12 inches. This here has to have a value of 1 because we don't want to change our rate of 10 feet per second. We want to multiply by 1 so that the value doesn't change, just the units change. Okay, so now we go to multiply and we're going to cross cancel. So we're going to cross out our feet. Then we're going to multiply numerator times numerator. So 10 times 12 inches is in the top. The bottom is 1 second times 1, which is just 1. To finish this up, 10 times 12 is 120 inches per 1 second. So let's go back and talk about how I said that when you multiply by 1, you don't change the value. Let's pretend that I called 2 people up to the classroom and I asked one of them to walk 10 feet in a second. I said go. In 1 second they had to cover 10 feet. And I had another student next to them and I said, when I say go, I want you to go 120 inches in a second. When I say go, who's going to get there? Who's going to travel quicker? 10 feet in a second or 120 inches in a second? Well, if we do this in class, hopefully you guys will realize that these two speeds are exactly the same thing. We took 10 feet per second, we multiplied it by 1, which didn't change its speed, it just changed the units. Okay? Alright, we're going to quickly try one of the multi-step ones, and we will do some more work with this in class. So flip your worksheet over. Alright, this one is a little trickier, and this is these boxes are a format that the high school uses, so that's why we wanted to do this. But to make this a little bit easier for you to see, we're starting out with 12 meters per minute. That's our speed. And we want to convert it to something that looks like centimeters per second. So that's how you read this problem. So this right here is really our fraction bar, and we want to get to centimeters per second. The high school staff just said that these boxes really helped kids to set this up. So just so you can get an idea here, we're going to multiply by a fraction. So that's what these boxes represent. Now notice that in this case, do you see that there's spaces to multiply by 2 different fractions? Well, the last problem we did, we only multiplied by 1 fraction. But if you look at our beginning units and our ending units, why do you suppose we're going to have to do 2 sets of multiplication? Well, hopefully you see that meters has to turn to centimeters and minutes has to change to seconds. So we've got 2 different units that have to change. In our last example, we had 10 feet per second. We were changing it to inches per second. Do you guys see that only the numerator of feet to inches had to change? We didn't have to change our denominators. So therefore, we only had to multiply once. Okay, so let's get this started. This is how we're going to do. You pick whatever unit you want first to focus on. So you can focus on meters first or minutes first. Okay, well, I'm going to do meters first. So when you think about meters, if you want meters to cancel, in this fraction, where are you going to have to put the unit of meters so that it will cancel with that numerator? Yep, we need to put it in the denominator. And then if you look over to our answer, what do we want meters to convert to? Centimeters. Then we ask ourselves, which is the bigger unit, a centimeter or a meter? Well, a meter is 1. That's bigger, so we make that the 1. Because a meter is bigger, we make that 1. Then we ask ourselves, this whole thing has to have a value of 1, so the numerator has to be the same length as the denominator. So 100 centimeters is the same as 1 meter, so we set that up. Now, just for simplicity's sake, when we were to multiply this, do you guys see that the meters are going to be gone? So now our numerator is centimeters, which is exactly what we want it to be. So now we have to focus on minutes changing to seconds. Well, notice that minutes is in the denominator. So if we want it to cross cancel, where is it going to have to go in this fraction? Good. It has to go in the numerator. And we want it to turn into seconds in the denominator, so we write that in. Now we ask ourselves, which is a bigger unit, a minute or a second? Well, a minute is bigger, so we make that the 1. And how many seconds are in a minute? 60. Now let's cross-reduce the units. Do you see that minutes in the denominator and minutes in the numerator are going to cross-reduce? So let's multiply now. In these fractions, we multiply numerator times numerator times numerator. So 12 times 100 centimeters times 1 is going to be 1,200 centimeters. 12 times 100 times 1. Our denominator is, there's a 1 there. 1 times 60 seconds. Okay. Now we're going to want to divide that. So 1,200 divided by 60 is 20 centimeters per second. Would be our best final answer. Alright, I expect you to have all of these video notes taken. If you miss something, please stop and rewind the video and watch it again. We will begin practicing this in class tomorrow. Have a great night.